All right, getting ready 32. We only have two problems to do here. They're both word problems, scenarios, and we need to use the elimination method, okay? We're not using substitution or graphing, we're using elimination. So, Nadia and Peter visit the candy store. Nadia buys 3 candy bars and 4 fruit roll-ups, okay? So that's Nadia, 3 candy bars, 4 fruit roll-ups. She spends $2.84. Peter buys 3 candy bars, but he can only get 1 fruit roll-up. Okay, his purchase is $1.79. So what is the cost of a candy bar and a fruit roll-up individually? All right, so like any scenario word problem, we need to decide our unknowns. And the question actually gives away exactly what they are. So when we write our let statements, let x and let y equal cost of a candy bar and a fruit roll-up, okay? So it doesn't matter which is which. I'm going to say x will be my cost of a candy bar, and y will be the cost of a fruit roll-up. Okay, now again, we have 2 unknowns. We must write 2 equations. Before you even start, let's think about what 2 sets of information do we have here. Sometimes we're given information where one equation is money and one equation is number of items. In this case, though, our 2 different sets of information, one equation will be for Nadia, and one equation will be for Peter. Okay, so those are my 2 equations. Let's write the one for Nadia. All right, Nadia's equation, she bought 3 candy bars. Well, each one costs X dollars, so 3X. And, so we're adding on to that, she bought 4 fruit roll-ups. Each fruit roll-up is Y, so 4Y. The total cost for her candy bars and her 4 fruit roll-ups was $2.84. Now we'll do exactly the same thing for Peter. He also bought 3 candy bars, so he also spent 3X for candy bars. But he could only afford 1 fruit roll-up, so he had just 1 Y, or just Y. And his total was $1.79. So, this elimination method, what we need to do first here is identify which set of variables would be simplest to turn into opposites. And what I mean is 3x and 3x. Are those opposites or close to being opposites? Well, they're the exact same term. So yes, if I just multiplied one of them by -1, they would quickly, easily be opposites. The 4y and the y wouldn't be quite as easy because they have different coefficients, but it would be possible. Okay, I could multiply the bottom equation by -4, and then I would have opposite coefficients. But I'm going to choose one of these equations, doesn't matter which one, and multiply it by -1, because that will result in having a -3x. So I'll take the top equation and say I'm going to multiply that by -1. Everything on the equation, both sides. So -1 times 3x is -3x. -1 times 4y is -4y. And don't forget the constant on the right-hand side. -1 times $2.84 is -2.84. Now, I did that because I wanted to have these 2 equations lined up with one set of opposites. And this is what I have here with 3x and -3x. Because my next step is to add the 2 equations. And the 3x and -3x totally cancel out. I don't have any x's left. And that's where the method got its name. It's called elimination because we eliminate one of the variables completely. Then we have this 1y minus 4y is -3y. And we have $1.79 minus $2.84 is -$1.05. So solving that little one-step equation, divide both sides by -3, y is equal to 35 cents. Now, what's that have to do with the problem? If we go back to our let statements, y stood for the cost of a fruit roll-up. So we know a fruit roll-up costs 35 cents. But that's only half of the question that I was asked. I was also asked to find the cost of a candy bar. So once you have one of your variables solved, substitute that back into any of the equations that you've already worked with. The purple one, the orange one, the green one, it doesn't matter. Now, of course, I would try to make it the easiest of the bunch, meaning I would not choose the one with all the negatives. If I had one that had decimals and the others didn't, I would avoid the decimals. If I had one that had fractions and the other ones didn't, try to avoid the fractions. But it doesn't actually matter which one. So I'm going to choose Peter's equation here and say 3x plus the 1y, I now know the value of y is 35 cents, so plus 35 cents gave his $1.79. To solve this, I subtract that 35 cents, the cost of the fruit roll-up, from his total. So I am left with 3 candy bars, cost Peter $1.44. $1.44 divided by 3 leaves me with x is equal to 48 cents. So what does that mean? The cost of 1 candy bar was 48 cents. So my 2 solutions, a candy bar, 48 cents, a fruit roll-up, 35 cents. Okay, number 2. A farmer noticed his chickens were loose and were running around with the cows in the cow pen. He quickly counted 100 heads and 270 legs. So how many chickens did he have and how many cows? So again, first we need our let statements. We are asked to find 2 unknown amounts, and they are the number of chickens and the number of cows. Now this really feels like you don't have enough information in the problem. And the reason for that is they're expecting you to know a couple of things just with your common sense, okay? If the 2 pieces of information are about heads and legs, then that's how we're going to make our 2 equations. One will be about heads and one will be about legs. Let's think of the heads first. The total heads is 100. Some of them are on chickens and some of them are on cows. How many heads does each chicken have? Well, 1. So 1x plus how many heads does a cow have? Also 1, so 1y. All the chicken heads plus all the cow heads equaled 100. Let's repeat that with legs. So how many legs does a chicken have? Each chicken has 2 legs. So 2 legs for each chicken, plus the cows have 4 legs. So 4 legs on each cow is equal to the total legs, 270. So you are expected to know how many heads and how many legs chickens and cows have. Okay, they did not write those numbers in the word problem. Now again, we're using elimination. So we need to turn one set of variables, either the x's or the y's, into opposites. Now either one would be pretty simple. If I multiply the top equation by -2, then I have opposites for x's. I did that last time, so this time I'm going to cancel out. I'm going to eliminate my y's. So that means I would want to multiply this top equation by -4. Remember to do it to everything on both sides of the equation. So that's -4 times x is -4x. -4 times y is -4y. And -4 times 100 is -400. I will then add these 2 equations. So 2x plus -4x is -2x. 4y plus -4y is eliminated, just like I needed to happen. Equals 270 and -400 is -130. Divide both sides by -2. So x will be equal to 65. So what does that mean? If I go back to my let statements, x stood for the number of chickens, so I have 65 chickens. I need to substitute that back into one of the equations. This top one certainly looks the easiest. The x plus y equals 100. So if I replace x with 65 and solve for y, that means I must have had 35 cows.